So once again, big round of applause for Professor.
Not work. Okay. Thank you. Good morning, ladies and gentlemen. Yeah. And thank you for inviting me and providing me such a nice opportunity with a huge amount of the audience. And I misunderstood the time, but it doesn't matter. We can make it shorter. Yeah, by omitting the so detailed equations. I'm Ryo from JIST, Japan, and today I'm going to talk about the new frontier of the computer science that is termed as material informatics. Okay. But anyway, I will explain this more in detail later. So let me introduce briefly about the JIST. I'm from JIST. JIST is one of the governmental institutes. Only have 900 students, but the faculty number is quite large in the sense of the ratio between the student and the faculties. And the JIST is quite international, and more than 40% of the students are coming from other countries. And India is one of the major of the foreign students, right? And that is actually the governmental pilot school. So it means that sort of they're quite aggressive to make the experimental, aggressive educational program. Okay. And one of the highlights of our institute is the supercomputer. That is my majoring field. And four supercomputers located inside JIST. Okay. And of course, the Tokyo University or Hokkaido University, a larger university, has many supercomputers, but the frequency of the replacement is quite more rapidly replaced. Okay. So we have 4 supercomputers, which is designed to replace every 4 years. So it means that every year we can enjoy the brand new machine. That is one of the advantage of our institute. Okay. Let's see. And my research group is working on some topics using such supercomputer. That is a quite interdisciplinary field. That is the message of today's talk. And we also constructed handmade computers. Yeah, that is quite enjoyable stuff. And I organized several times about how to construct a handmade supercomputer and how to run the parallel simulation by using such kind of things. And even in Kenya or even Ghana or every country like Thailand or maybe in India, we organize such kind of workshop. But anyway, what is my majoring topics? That is not purely the computer science, not purely the computer architecture, but the material science. So today's message of my talk is just the interdisciplinary stuff. Okay, so the message is getting out of the conventional category is the exploring the new frontier. So some of you majoring what kind of subject? Who are majoring in the computer science? You are the computer science people. And some sort of medical, biological stuff. So, say again? Huh? Management. Okay, yeah. Anyway, my message is that your major, now you are working, it doesn't matter in whole your life. You can change everything to explore the new frontier. Okay? The getting ability to categorize what is this is the first step for student. But the next step is the getting out of the conventional research field to be the first primary person to explore such a new research field. Okay? And the new categories have emerged by this way. Actually, the computer science was not there maybe 40 years ago or 50 years ago, but it emerges just recently. Okay. So this is my self-introduction. I wanted to be an engineer in mechatronics, but I failed to get such chance. And then I changed my interest into the condensed matter theory. That is the physics, right? So I did the undergraduate in the physics theory. But after that, I had to shift into the computational researches. That is in Cambridge, right? And then finally, I got a job working on the supercomputing stuff. When I was an undergraduate, until I was a postgraduate, I hate the computer. I couldn't typing it. But now I am the representative person in Japan handling the huge supercomputer. So that is quite a big change. So one of the central topics today is the transmission of the life. So I will be an appropriate person to talk about that. Okay. What is the aim of the higher education? Higher education is to have the ability to make consideration and discussion, not acquiring the specialized technique. That is the technical school stuff. So the higher education, so this is a skill of one who completed higher education. So your major in undergraduate course is just an example material to learn such ability to make a consideration and a discussion. So anyway, work hard in your undergraduate topics to acquire this kind of ability. And then the open-minded to shift your majoring field, right? So do you like your major now? Right? Right? Okay. Then let me start the material science. That is different from the computer science or the management. But the content is not so difficult stuff. Anyway, the power and the impact of the material science. Let's think about how to speed up your computer. What is the possible way? Huh? Huh? So, of course, for computer science people, you can see that developing new algorithm with more efficiency. So the algorithm stuff, that is the computer science stuff, right? Or cache or memory stuff. That is quite technical computer architecture problem. Or how designing new instruction set like a MISC or SIMD or whatever. But, such and such. But what is the most striking impact is the new material, right? Of course, these make your computers accelerated, but if you replace the silicon into gallium arsenide, that is new materials, the speed up factor would be 10 or 100 or 1,000. So then one of the attraction of the material science is such kind of big impact. Okay. Next example. So we want to improve the environmental issue, right? So what is the possible mean? Of course, designing law or legal system is one of the possible ways. So this motivated some younger people learn the law school or something. And the recycle system or administration system is another possibility. And that stimulates the younger people to go to the administrator, like a lawyer or a politician or whatever. Of course, these are good for the environmental issue, but the most striking impact can be coming from the new material, like a solar cell or hydrogen storage or whatever. So this is the power of the material science. Okay? Another example, you want to have the better speaker or better phone, right? Of course, the designing acoustic system or signal processing is the possible way, but actually recently, the rapid improvement of the quality of your speaker or earphone is made by the new magnet. That is another impact of the material science. Okay. So what is the material science? Of course, you know that the chemistry or physics, so maybe you don't like the physics, right? After the discovery of the quantum mechanics that is made in early 90s, make it mixed up every traditional field like pharmacy or metallurgy. All these different fields comes into the one research field. That is the material science. Okay. Every material consists of the electron and the nuclei, right? And the quantum mechanics says that the human being discovers that in every materials, electrons are dominated by unique equation. Okay. So naively, we expect the electron inside the metal and the electron inside the biological system behaves quite differently, right? So dominated by different law. But what we found is that all electrons are dominated by unique equation. Then, this is the equation to dominate every kind of electron, even inside the biological system, even inside the glass or even inside the metals. All the behavior is described by one equation. Okay? Then, in order to work on chemistry or pharmacy or metallurgy, just sticking on this equation, then this equation gives you every information. Okay? So we can just concentrate it on this equation. Then the computer comes. Emergence and utilizing computer. Okay. Computer can handle equation to be solved, right? So even the chemical reaction, just simulating such equation can give every kind of information about chemistry. Okay. So performing chemical reaction inside the virtual space in computer. That is the idea. Okay. Every variety of materials in our world can be generated by the possible combination of up to 100 elements. And the computers are very good at to surveying every possible combination. That is the matter of the data science. Okay? This is the idea. The compounds inside the PC. Nowadays, even in your laptop, you can compose your compounds and make them to react, chemical reaction inside your laptop computer. Okay. So that is the material informatics. Again, the idea is that our, let's see. So our world is composed of every possible combination of the 100 chemical elements. And then by using the computational power, surveying every possible combination to make reaction or prediction of the material prediction by using computers. And even using artificial intelligence, we can make it more effectively to survey every possible combination, because the naive combination makes you the vast time of the search. Okay. So that is sort of the new frontier of the data science or computer science. Okay. And looking at this, the computer history, originally computers are for computing. Computer means a computer, okay? Not for internet, originally. Okay? But so the computer has been used for the numerical analysis as computer it is. Okay? And at some point it comes to different direction, like a floating operation to make it more aggressive about the numerical analysis comes to the supercomputer research field, whilst the integer operation is utilized for the business handling, like a word processor or a calculator. So it eventually comes to the internet technology. Maybe you are now working using the internet technology. But anyway, the numerical analysis is has been stimulating the cutting edge of exploring the more performance of the computer. Okay. So this is an early computer, and the hand loaded computer is used. Anyway. Okay. So even still now, material science is one of the largest field of the numerical analysis, and one of the best stimulator to the computer performance, like acceleration of the processor or memory access. Okay. So maybe your first impression is that computer science and the material science is quite different research field, but it is actually quite come closer each other. It has been a closer relationship. Okay. So the material science as an information science, as I explained before, in the context of the recent data science, the information science or data science can be used to make it effectively survey all the possible combination. So there is, now you understand, there is some research field about computational material science, which handling the equation, simulation of the equation dominating the electron's behavior. So of course the materials simulation ranged from the continuum level to the electronic level. And what I'm working on is the most deeper level of the computational material science. That is termed the ab initio simulation. Okay. Ab initio calculation is such kind of black box. If you gives the position of the element, the here oxygen, here hydrogen, or here nitrogen, then the black box gives you the energy of the system. But do you want to evaluate the energy of the system? No? Who want to know the energy of the system? Because the energy of the system is quite boring quantity. Nobody wants to evaluate that. So then, what is energy? Energy is sort of the measure of the stability. If you have the lower energy, it means that the system has more stable. Okay. So, but even still now, I don't think there is anybody who wants to evaluate the system of the energy, because that seems quite boring. You want to know much more fashionable, much more interesting quantity. Okay. But if you can evaluate the energy of the system, you can predict something. Okay. So there are two possibilities of the molecular structure, and which structure is stable. Then, if you can evaluate the energy of each configuration, then the lower energy gives you the answer that which structure is stable and which structure is likely to exist in nature. Okay. Maybe you have seen this kind of picture. This is the water molecules. And the textbook says that the angles between the hydrogen is 104 point something, right? But who know that? We cannot see the microscope, right? This is actually the computationally predicted. Yeah. So if we plot the energy as a function of the angle theta, then the minimum angle gives you the answer. What angles the molecular structure is. Okay. So this kind of stuff. So this is one of the part of the DNA stuff, right? And if you have the black box to evaluate the energy with fixed spacing d, you can plot this point, you can plot this point, right? And plotting, and then you get some curve there. Okay. And from this curve, what kind of information you can extract? The first one is that the minimum position gives you the prediction of what spacing inside the DNA is realized. Okay. Bonding length. And the depth of the well gives you the rough estimation about up to what capacity of the heat then this molecules breaks. Okay. So such kind of information we can extract by using such apparently boring black box to evaluate the energy. So we are now working on the development of the energy of the system. Okay. So let me, and such kind of stuff is also used as a drug design. Okay. And the catalyst design and the steel industry, even in the steel industry, they used this kind of black box. Okay. Let me skip this one. So up to when? Another 5 minutes. Okay, yeah. So such kind of ab initio simulation now comes to the drug deliveries or biotechnology or a steel industry. So it quite recently it comes to the industrial topics. It becomes, but the point is that human resources at present, okay, who can handle with this kind of stuff? Okay. The computer science student says that, oh dear, that is a quantum mechanics. I don't like that, or that seems too difficult for us, right? And for the student of the material science, they say, oh dear, I'm not so good at computer. I don't like handle the supercomputer, whatever. So now, obviously, the lack of the human resources. Okay. So now there is large movement, mainly from U.S. government and even Japanese government, to develop such kind of human resources who can acquire the computer science as well as the material science to handle this stuff, because that has widely been used recently. Okay. So the outline is why we want to evaluate energy, because by evaluating energy we can predict the microscopic molecular structure. Okay. And in my original plan, I will describe how to evaluate energy and how to solve the equation, how the parallel computer is used. But time of the limitation, just let me flash the pictures, which might be attract your interest. Okay. So this part is obviously very boring for you, right? The mathematics, so I will omit this part. Especially this part is very complicated mathematics. Okay. Let me skip this part. And the final goal for us is we want to get the exact solution of this equation. But there is some beautiful mathematics theorem that the exact solution of this equation minimizes this quantity. And this multi-integral quantity can be evaluated by using the technique of the Monte Carlo sampling technique. So, solving this equation, the problem of solving this equation can be transformed into the equivalent problem of the numerical minimization, because the exact solution minimizes this quantity. Okay. So what we have to do is to implement how to perform this numerical minimization. And the numerical minimization is a quite common problem. Most of the computer science students are working on this kind of stuff, right? At least at the textbook level. And this evaluation of this integral can be performed by using the Monte Carlo technique. That is just sampling stuff. Okay. So for sampling stuff, what matters is the number of the sampling point, right? So in order to earn the sampling point as much as possible, the parallel processing is very useful, because using the same time, you can get more sampling point. So this is where the parallel computational technique is used. Okay. So in order to get to implement the parallel computers, you can increase the number of the processors. But the problem is that even you increase the number of the processor cores, your performance is not surely increased. Sometimes it saturated like this. Okay. So because for the problem, if we want to evaluate some point, we have to wait some other answers from neighbor. Right? So this is a big problem to bring us such kind of performance saturating. Okay. So in order to overcome this, there is so many techniques and many knowledge is used, especially in the computer science research field. Anyway, I will skip the stuff in detail, but by using this kind of powerful computers inside the research group, we work on that. So this is using 2,000 core. It comes to around 2,000 core, but still saturating. Okay, but 80,000, it's still that. But by making some improvement of the communication, it comes to more linear. It becomes. Okay. So now we can make it 500,000 of the cores. We can make it 500,000 core acceleration factor. So by using such kind of power of the computational stuff, we are now developing the material informatics at the JIST Institute. So that's all for my talk. Thank you very much for your attention. Thank you.
Thank you, Professor Maizuno, for sharing, elaborating such a very big topic, material energy. I think first it is very important for us to understand the relationship between the materials and energy, and how IT can help to flow the energy from material to the application part. So thank you very much, Professor Maizuno. And now I would like to have the queries, especially from the young students. Can we have few hands, those who want to have some queries? I will give you some time, please make your queries, and that time I think sir have something to ask.
Thank you, sir. My question is, we can say everything is energy. Because organism, if we break it, then become organ, then break it, then tissue.
Yes.
Then we break tissue, then it becomes cells, then molecular structure.
Yep.
So now my question is, because human brain is the best energy in this universe, because we can give direction to the human brain. We cannot give much more direction to the lion. We can give much more direction to the animals. But we can direct the energy of human because having some senses.
Yeah.
So my question is, how molecular structure is created? Because it is the smallest unit of material. So how to molecular structure is created in a human brain?
Yeah. In general, that is difficult to answer, but there is some research field which tackled with how the molecular structure emerges, like self-organized. You see the patterns of the molecular system emerges automatically. Yeah, so that is because each molecule can feel the attraction.
Yes.
Yeah, and then come closer to get like that. So yeah.
So I have also always thinking about it, but it's my thinking that we all are having signals and different frequencies. So signals create molecular structure. Is it right?
Let's see. Yeah, that's right. Yeah, the molecular interaction can be decomposed into the frequency range. Yes. And by using the frequency synchronization, they can communicate each other to come closer to. Yeah.
Yes. Yeah. And a signal is created out of knowledge. So knowledge is very minute. If we have a right kind of knowledge, then we can create a right kind of frequency and signals. And due to the signals, we can make our body very powerful. Yeah. Because the smallest, we can say everything is energy, because the smallest part of the material is energy. So if we read good thing, if we have a right kind of knowledge, then we create a better signals, and due to the better signature, better molecular structure, and in this way we can keep our HR in a good state of mind. Because the best energy and best component in a business organization is HR. Because in every human body, we are having around 50 trillion cells. Around 50 trillions. If we place 12 zero in front of one, we can create trillions. So 50 trillion cells, and every cells we are having 8 GB memory, and every cells we are having further around 30 trillions DNA. Think over it, how powerful is the human brain and human body is. So in a business organization, if we are dealing the human, then it is a magic. So my understanding is, if we create a right kind of knowledge, then we can create a wonder in the business organization as well. Thank you. Thank you, sir. Thank you.
Thank you for your comment.
Yeah, just let me add one more thing, that what is important here, if the molecules can meet with the energy, then the molecules can change and can make new something. So what is important? The meeting part of molecules with energy is very important. Molecules can be evolved, can be changed, can be adapted to different shape, but the energy need to be consumed by the molecules. So I think maybe I have one query, that how the AI can help to develop something new in future, few new molecules.
Yeah. Anyway, in order to make some computational experiment to how interact to get a new structure, we have to set up some initial configuration. Which molecules is set here, which molecule is set here. And the possible combination of the initial configuration has a vast number of such kind of stuff. So the AI can gives you the effective choice. What is the next to be prepared, right? Like if you work on the Amazon shopping, right? Again and again you purchase something, your choice is well chosen, and the computer system can provide you a proper proposal. So such kind of technology can be used to provide the quite likely combination of the initial stage. And then the computer simulation make a simulation. So in order to prepare the initial set effectively, the AI is used.
So AI can help you to consume the energy and to evolve molecule as of you, I think. So can we have some more queries from students? If not that, because we are running out of time, but you should take some time in lunch break or coffee break